Students, myself Mehul Kodiya. So in today's session we have to discuss one experiment related to gyroscope. The subject name that is dynamics of machinery, and the experiment that we have to perform, that is understanding of gyroscopic effect using motorized gyroscope. So first of all we have to understand the basic working principle of gyroscopic effect. Okay. So this is the experimental setup available in our institute, that is motorized gyroscope. The main component of this setup, that is one rotating disc and one electric motors. Okay, so first we have to understand what is a gyroscope. So what is the definition of gyroscope? So gyroscope is a device for measuring or maintaining orientation based on the principle of conservation of angular momentum. Okay, so first we have to understand what is angular momentum. So there is two types of momentum. First one, that is a linear momentum, and second one, that is a angular momentum. As you all know, the concept of momentum, that is, it is nothing but it is the mass into velocity. Once we discuss about linear momentum, at that time we have to multiply mass with its linear velocity. But once we discuss about angular momentum, at that time we have to multiply mass moment of inertia with its angular velocity. And the direction of angular momentum we can find using the right hand thumb rule. Okay, means finger indicate the direction of motion and thumb indicate the direction of force or direction of momentum. Okay, so this is the concept of gyroscope. Now we have to understand working principle of gyroscope. So in gyroscope there is one rotating disc and one shaft. If you change the orientation of the shaft, at that time gyroscopic effect is occurs. There is two types of gyroscopic couple. First one, that is a active gyroscopic couple, and second one, that is a reactive gyroscopic couple. So basically in any of the instrument we realize or we feel the effect of reactive gyroscopic couple, because a active gyroscopic couple, that is the imaginary parts. Okay, now first we have to discuss that what is the application of gyroscope. So application of gyroscope in aeronautics and in aviation. So in aeroplane and in aviation, gyroscope used for maintaining the orientation of the gyroscope in the space, and also gyroscope used for the changing the altitude of the position of aeroplane. Okay, so like helicopter, some hovercraft, some planes, etc. rely on gyroscope to prevent them from flipping over on going to spin. Okay, so in spacecraft rely on gyroscope for orientation, while in space, whenever aeroplane take turn either in left hand side turn or in right hand side turn, at that time gyroscopic effect occurs. Okay, aircraft and aircraft autopilot rely on gyroscope to account for change in direction and altitude. So basically gyroscope used in aeroplane for changing the altitude and also change the direction, means either aeroplane take left hand side turn or right hand side turn. Okay, so this is the application of gyroscope in aeroplane. Now we have to discuss application of gyroscope in ship, in naval fleet. Okay, so there is a three types of motion occurs in ship while moving on the water surface. First one, that is steering motion, second one, that is pitching motion, and third one, that is a rolling motion. So basically we have to control these three motion using the gyroscope. So what is steering motion? Either ship take left side turn or right side turn, that is the steering motion. Second image indicate the pitching motion, means cyclic up and down motion of ship due to water wave, that is the pitching motion. And third one, this is a rolling motion. For the rolling motion, if you observe, see from the front view, at that time this is the third figure indicate the rolling motion, cyclic up and down motion of starboard and ports. Okay, as you all know, the left hand side of ship consider as a port side and right hand side of ship consider as a starboard side. Okay, so this is the application of gyroscope in ship. Now we have to discuss the application of gyroscope in automobile. So in automobile there is no any gyroscope provided in the body. This just we realize or we feel the effect, gyroscopic effect in car or in bikes. Clear? So gyroscopic behavior is used in the racing car industry. Clear? So whenever you drive a car at very high speed and you take turn, either left side turn or right hand side turn, at that time your outer will try to lift it. Clear? So this is just because of centrifugal force and gyroscopic effect. Clear? So gyroscopic behavior is used in racing car industry. This is because car engine acts just like a big gyroscope. Car engine is just like a big gyroscope, because in any of the equipment, if any of the rotating disc is there, at that time that body considered as a gyroscope. Clear? If at that time that body we can consider as a gyroscope. So in engine we can consider flywheel as a one rotating disc. Clear? So we can consider car engine is just like a big gyroscope. Okay, because of the gyroscope, force from the engine depend on whether the engine spinning clockwise or anti-clockwise. The car nose will be forced up or down, either flywheel rotate in clockwise direction or anti-clockwise direction. Based on the direction, gyroscopic effect generated. Okay, so this is the discuss for the gyroscopic effect on a four-wheeler. Now we have to discuss gyroscopic effect on two-wheeler. So whenever you ride a bike, clear, and then once you take turn, either left side turn or right side turn, at that time the orientation of bike try to incline with vertical axis. Clear? Means your bike make one angle with vertical axis, that angle consider as an angle of heel. Okay, so once you take turn, at that time your bike little bit inclined with vertical axis, but you cannot fall down. Clear? This is nothing, this is just because of gyroscopic effect and effect of centrifugal force. Okay, so wheels on motorbike act as a gyroscope. Clear? I already say that any of the body having one rotating disc, at that time that body we can consider as a gyroscope. So in once we discuss about motorbike, at that time engine as well as wheel consider as a rotating disc. Okay, that's why we consider bike as a gyroscope. Okay, so in a gyroscope used for the balancing purpose in aeroplane, in ship, in four-wheeler and in two-wheeler. Okay, now we have to understand the experiment motorized gyroscope. Okay, so first we have to discuss the nomenclatures that we use in our experiment. So first of all we have to measure angle. Clear? So d theta consider as an angle of precision, and we have to measure angle in degree. Second one, that is dt, time required for this precision. Third one, that is g, acceleration due to gravity. Next one, that is capital I, moment of inertia. Next one, that is capital L, distance of weight for the center of disc. Capital N indicate revolution of disc spin. Small r indicate radius of disc. T theoretical means theoretical gyroscopic couple. T actual means actual gyroscopic couple. Capital W indicate weight of rotor disc. Small w indicate weight of pen. And angular, so omega indicate angular velocity of the disc, and omega p indicate precessional of yoke about vertical axis. Okay, so this is the nomenclatures. Now we have to understand the experimental procedure. Clear? So we have to understand experimental procedure using this video. So there is a one gyroscopic setup. This one is the dimmer. Using dimmer you can increase or decrease the speed of the gyroscopic disc. Once we increase the voltage, at that time speed of gyroscope is increased. So there is in this setup there is 3 degrees of freedom. Okay, first one, that is axis of spin. Second one, that is axis of precession, that is vertical axis. And third one, that is the horizontal axis, that is the consider as a axis of gyroscope. Okay, so this is the setup of gyroscope. we have to there is a three condition. First one, that is axis of spin. Vertical axis considered as a axis of precession. Vertical axis considered as a axis of precession. Third axis, that is the z axis, considered as a axis of gyroscope. Okay, we have to wait until the gyroscope come in the steady condition. Okay, we have to measure the RPM using the tachometer, and we have to use contactless tachometer, and we have to measure RPM. We have to measure the disc rotation in RPM using tachometer. So this is the contactless tachometer, and using this tachometer now we have to measure the RPM of the disc. Okay, so we have to find the reading, that is 2564 RPM. Clear? So now the gyroscope come in steady condition. Now we have to apply load. Clear? So either we have to apply load in 1 kg or 1.5 kg or 2 kg. Okay, so this is the setup of gyroscope. We already discussed the working principle of gyroscope, and as you all know, any of the body will move on the direction of resultant force. If we applied two force in two different direction in single body, at that time that body will try to move the direction of resultant force. So first, the direction of momentum of rotating disc we have to find out using right hand thumb rule. Then finger indicate the rotation of disc, and thumb indicates the direction of momentum. So direct momentum of disc occurs in forward direction, and once we applied load in downward direction, at that time the second force occurs in horizontal direction. Okay, so we have two force, one in forward direction and one in horizontal direction. So body will try to move in the direction of resultant force. Okay, so direction of resultant force, that is of resultant force. Okay, so direction of resultant force, that is in inclined direction. So body will move in the inclined direction. You can see in this video. Clear? The gyroscope try to move in the rotate in the left hand side. Okay, so now we have to perform this experiment. First of all, we have to set the angle of gyroscope at 0 degree. Okay, so we have to set and we have to set the scale of gyroscope at 0 degree. Okay, and we have to perform this experiment at constant RPM. Okay, so now we have to put weight on the gyroscope, and we have to measure time using stopwatch at particular angle. Okay, means once we applied load on gyroscope, at that time gyroscope try to rotate in left hand direction, and for particular angle we have to decide the angle at 80 degree. Okay, so we have to measure the time up to the 80 degree of rotation of gyroscope. Okay, so in gyroscope basically there is a three condition we have to discuss. First one, that is a steering motion. Second one, that is pitching motion, and third one, that is rolling motion. Okay, so now we have to measure the RPM using tachometer. Okay, so we have to just come for the steady condition, and we have to measure the RPM. Once we measure the RPM, we have to apply the load. Okay, once we applied load, we have to measure time using stopwatch. Okay, so now we have to apply load, that is 1 kg. Now we applied this load, and using stopwatch we have to measure time. This is the original position of gyroscope at 0 degree. Now gyroscope, and we have to measure time, that is 6.77 seconds. Okay, so now we have two data, angle and time. Clear? As you all know, we can find angular velocity. We can find angular velocity using value of theta and time, like omega p is equal to d theta by dt. Clear? And we have to consider value of theta in radian. Once we have to convert any of the value of angle in radian form, at that time we have to multiply pi by 180. Okay, so we have to measure basically three data. Omega is equal to 2 pi n by 60, and that is the RPM of disc. We already measure using tachometer, so we can find using value of RPM, we can find value of omega. we have to find value of omega p. Omega p is equal to d theta by dt. Now we have value of theta and also we have value of time. So based on we can find value of omega p, angular velocity of axis of precession. Okay, so now we have value of omega and omega p. Now we have only one value is remaining, that is capital I. Clear? So value of capital I means what? Capital I indicate mass moment of inertia, and equation of mass moment of inertia, that is mk square. Clear? So instead of m you can write w upon g. Now we have weight of a rotor disc and capital K, that is the radius of gyration, and radius equation of radius of gyration, that is k is equal to r by root 2. Okay, so based on this, and what is the equation of gyroscopic couple, that we already discussed in theory, that is I omega omega p. If you have to multiply these three value, and you will get the answer of gyroscopic couple. So given data, first we have to understand given data. Acceleration due to gravity g, the value of g, that is 9.81 meter per second square. Radius of disc small r is equal to 0.15 meter. Weight of rotor disc capital W is equal to 5.42 kg. Distance of weight for the center of disc capital L, that is 0.185 meters. Okay, now we have to make one observation table. In observation, you all know we observed the RPM of the disc. Also we applied load. Second thing, we measure the angle movement, and also we measure the time required for the turning of angle. Clear? So we set the disc at 1600 rpm. We applied load 1 kg. We decide to move angle up to the 80 degree, and we take we measure the time required to move gyroscope up to 80 degree, that is 6.77 second. Clear? So we take one observation. You can apply load 1.5 kg and you have to take second reading. After that, if you applied third load as a 2 kg, and you have to take one reading. Okay, now we discuss just calculation of for the first reading. Now we have to calculate that value. Omega is equal to 2 pi n by 60. So you have to just put value of n 1600 over here, and you will get answer of omega, that is 167.46 radian per second. Also we have equation of omega p, that is d theta by dt. So put value of theta 80 degree over here, put time, that is 6.77 second over here, and you will get answer of angular velocity of axis of precession, that is 0.206 radian per second. Third one, capital I, mass moment of inertia. Equation of mass moment of inertia, that is mr square by 2, because the we have to consider mass moment of inertia of rotating disc type. Clear? Moment of inertia of rotating disc type. Clear? So equation mr square by 2, instead of m we can write w upon g. Put value over here, all the value over here, and you will get answer of capital I, that is 0.59 kg into meter square per second square. Okay, now you have to find out value of gyroscopic couple, theoretical gyroscopic couple. So we already discussed and we derived the equation of gyroscopic couple, that is I omega omega p. If you multiply above three value, and you will get answer as a 20.35 Newton into meter. So this is the answer of theoretical gyroscopic couple. You can also find value of actual gyroscopic couple using equation of torque. As you all know, equation of torque, that is load into distance. So we applied load 1 kg. So you have to consider 1 kg into, if you multiply value of g 9. So you can also find actual gyroscopic couple using W into L. Clear? This is the equation of actual gyroscopic couple, and in calculation we find the value of theoretical gyroscopic couple. After that, you can compare the value of theoretical gyroscopic couple with actual gyroscopic couple. Okay, now this is the result table. In result table, we find value of I, that is 0.59, value of omega, that is 167.46, value of omega p, that is 0.206, and value of theoretical gyroscopic couple, that is 20.35 kg into meter. Clear? Also you can consider find the value in Newton into meter. Okay, so this is the practical of motorized gyroscope. The precaution and maintenance instruction is given, that is never run the apparatus if power supply is less than 200 volts and above 230 volts. Second, before start the motor, set dimmer state at 0 position. And third one, that is increase the speed gradually. Don't increase speed because if you increase the speed, then your fuse will be not working properly. Okay, so this is the precaution and maintenance instruction. And last one, that is conclusion. So we conclude from experiment that when the right turn under a clockwise direction condition, the effect of reactive gyroscopic couple will be to dip noise and rise the tail. And in anti-clockwise condition, effect of reactive gyroscopic couple will be to raise the nose and dip the tail. Okay, so once we rotor rotate in anti-clockwise direction, and if you try to load apply in downward direction, at that time body will try to move in left hand side. Clear? But if rotor rotate in clockwise direction and you applied load on gyroscope, at that time body will try to move in right hand side. Clear? So this is the conclusion of motorized gyroscope. Thank you.